taking the valuable time to attend this conference. What I would like to introduce you to is Belimo Residential. Starting in January 2016, Belimo has started a new marketing campaign to bring our products and solutions into the residential marketplace. So, the context of this discussion will revolve around air balancing a residential system and the ins and outs that go with it. Our overall goal is to position Belimo as a leader in residential forced air and hydronic systems marketplace by providing solutions for improving energy efficiency, occupant comfort, and making it easy to select and size and install, balance, and show performance of systems. As with most technical items, we need to start with some balancing assumptions or some base parameters. Certainly there's the discussion of certification, using a certified or testing and balancing agency that can train service technicians to become certified in balancing. There's also, of course, load calculations of the home, properly sized equipment, quality installation procedures and techniques. Of course, we can't have leaky ductwork, otherwise our testing and balancing doesn't really work. The home envelope needs to be ideal or intact. And of course, the equipment needs to be operational, including all the accessories that may be involved in balancing the system. We'll go into a little bit more detail as we go. So when we look at the opportunities from an idealistic perspective, what does an industry leader look like to us? Easy Living HVAC is a area that we can look at. So we want to provide comfort on demand, energy with no waste, efficient planning, installation, customizing, or commissioning. We, of course, want to enable self-diagnostics and maintenance. And these are things that are goals to shoot for, to help homeowners, contractors, and occupants achieve comfort. So through our analysis of the marketplace over the last period of time, approximately 2 years, what is the current state of residential zoning? And for that matter, balancing. The goal, of course, ultimately is simplicity. Simplicity in the fact that we want to provide comfort to the occupant. Unfortunately, we have always the layers of complexity that cover the intended goal of providing comfort. Complex designs, construction techniques, installation techniques, the homeowner's requirements, manufacturer specifications or unique characteristics to manufacturers, one versus the other, local codes, national codes, competing standards, and of course the almighty rule of thumb. In residential construction or residential HVAC, the rule of thumb is used more often than we would like to see it. And of course, the sales channel. Once you install a $15,000 or $20,000 system in a home, whose customer is that? And how do you maintain that customer? So these are all complex topics that revolve around simply providing comfort. And of course, customer support is the last one. So when we look at the technical aspects, we can look at simply one agency. We look at ACCA. ACCA develops documentation for load calculations, Manual J. They provide a manual for system and equipment selection. residential duct system sizing and design. They have a manual also for residential zoning. We have competing standard for ASHRAE 92.2 for ventilation. And of course, for this discussion, balancing and testing of systems. So you can see that just from this one industry organization, we have many different technical competency areas to contend with, which means for the contractor, for the everyday technician, things can get quite confusing. So, as we dive deeper into balancing the system, we want to talk about just a brief overview of some of the characteristics, both from measurements as well as the devices that you typically use. This is not an in-depth, detailed discussion on these areas, but just from a higher level, we may use these terms. Of course, we have flow hoods, which are used, low volume flow hoods, which are used to actually measure the amount of air coming out of a diffuser going into a zone or into a space. Anemometers, which are typically handheld devices, both hot wire anemometers, and then you have the rotary vane anemometer to measure flow. Manometers for pressure measurements, and of course pressure gauges. They could be installed or a service technician's handheld device. Of course, with those pressure gauges or pressure measurement devices, you have the need to actually measure the pressure in the system. So you have pressure taps, and pitot tubes are very commonly used in our industry for making measurements. So once you have the devices in hand, of course now you need to start making some measurements. Some terms that we'll use: static pressure, total pressure, velocity pressure, velocity, cubic feet per minute. You know, these are all obviously common terms in our industry. And some of the most important techniques that we can use are to accurately measure the airflow in a duct system at various points throughout the system. Of course, this is a labor-intensive topic, and ultimately, as I said in the beginning, this is something that Belimo wishes to improve in the future, to make these things, to make the airflow characteristics in a system transparent. So, even if we look at a very simple duct system in a home, what are the dependencies to deliver the correct air, even in a simplified system, to the proper zone? So is duct performance static? For example, is the airflow static for a system that simply has a heating and cooling mode, where we have a high fan speed and a low fan speed? And how does that affect the proper air volume getting to the proper room in a home? So this starts the discussion of balancing. Ultimately, is occupant comfort ensured when we leave the job site? So we can look at airflow balancing, and just as a quick reference, the following steps are based on the ACTA standard from 2009. I'm sure there's an updated version, but just to give you a reference. Their procedure is an 8-step balancing process that includes, of course, planning, balancing the air mover. That means, well, first planning, understanding the system, looking at the home plans, the design, HVAC design plans, manufacturer's data sheets of both the equipment as well as the accessory devices such as the zoning or humidifiers or air cleaners or filters, etc. And of course, having a complete complete set of formulas that you can use to calculate your airflows. Second step, balance the air mover. What does that mean? Well, are you really getting 1,505 CFM out of your air handling unit? Is it functioning correctly? You can't end with 100 CFM going to a room if you're not sure if you have the discharge 1,500 CFM in the beginning. So understand the air coming out of your system first. Then we have, of course, they recommend the ability to adjust the airflow going through a trunk or a branch run of ductwork and ultimately into the desired room itself. So there's various ways of doing that. From that point, we need to adjust any equipment, identify if there's any leakage. Are there areas in the ductwork that the flex duct has fallen off, or there's a seam that has not connected correctly, or just simply seams that are leaking. They recommend for variable air volume or variable VAV systems to consider diversity. And diversity in this case is simply the ability to send or to load match the room to the exposure, sending airflow in one direction versus the other. Of course, balancing the outside air and the exhaust air. This can be considered an accessory piece of equipment, but we have dedicated systems for balanced outside air or integrated outside air, and it should be looked at uniquely as its own separate step. And then, like most every pressure-dependent system, repeat the process. And why would you repeat the process? Well, if you adjust, well, actually, let me go to the next slide. So if we're looking at applying those 8 steps recommended by ACCA, of course, planning, balancing the air mover, or understanding the measurements or the flow coming out of the air mover, the ductwork, balancing the actual or adjusting the flow to the rooms, adjusting any other device in the system, such as humidifiers or flow-through humidifiers, evaluate the duct leakage on the fifth step, and on the 6th, the balancing for diversity or different room exposures. 7th step, balancing exhaust or outside air exposure or systems. And number 8, repeat. So if we came up to the fictional duct system and adjusted the manual damper on the upper zone in a pressure-dependent system, which means the pressure in the ductwork is dependent on all other devices in the system. So if we adjusted the top-level manual damper, it certainly has an effect on the remaining dampers, manual dampers. So the flow, once you adjust it, the flow through the remaining ducts, even though it's in manual position, will be impacted. So that's where the repeat process comes in, is they want you to go through an iterations step of ensuring that the flow is getting to the proper zone. So, what are some of the devices or components in the system used for manual balancing? We can focus first on hand dampers. Of course, there are hand dampers integrated into branch takeoffs. So it's simply a hand quadrant with a mechanical screw stop, often difficult to indicate what the position is, often difficult to find them even in the system. A better system might be one with a hand quadrant with mechanical stops, integrated, maybe a little bit more expensive, but at the same time gives you a little bit more functionality during your commissioning and testing and balancing. There are also registers, discharge registers that have integrated dampers, and it's not necessarily recommended to balance a system based on a register position, simply because as you begin to close an air register, you start to increase the air velocity across or through that diffuser, and you change the parameters of throwing the air across the room too high of a velocity. So it's best to have manual dampers installed for this manual balancing process. Of course, when you have a system that has zoning, you also have some balancing opportunities at the zone damper. The Belimo zone damper actuators have both a minimum position stop and a maximum position stop built into the actuator. So on both the clockwise and counterclockwise side of the actuator, you can adjust up to 65 degrees on each side. Not in total, because then effectively, if you adjusted this on both sides, your actuator won't be able to move. So it's very common to adjust a minimum position so that you can have a little bit of air volume moving through the system during ventilation mode or fan-only mode, and of course using the maximum position as your balancing tool to limit flow through that particular branch run or zone. So manual balancing, when looking at constant volume systems, single speed or multi-speed furnaces or air conditioning systems, which typically utilize high speed for cooling and low speed for heating. When you have a damper, let's say that again the top damper, that you manually adjust it for the maximum flow or high speed fan in the cooling mode, are you really ensured that you're not overheating the space in the heating mode even though you have a lower fan speed? So this is where homeowners' complaints start coming in, where the need to actually go back to the home and rebalance the house is very common. And often that's not a cost of the total installed cost of a job that most people consider. When you roll a truck back to the home to satisfy a comfort complaint, that is the result of improper balancing. So there's ways to combat this, setting up the system initially, using the manual dampers, using the diffuser, maybe, as a last resort, and of course using your measurement devices and flow techniques to verify the proper flow as designed according to your load calculation and how much energy it will take to satisfy the load of the room. Of course, ultimately we want to be able to compare the design flow or the design cubic feet per minute versus or compared to the installed and delivered airflow to a particular zone. These are all things that we can compare. Unfortunately, they also commonly take a lot of time. So if we take a second to look at a traditional zoning application, I want to first say that zoning should, I highlighted here a discharge air temperature sensor. Zoning should be done with a discharge air temperature sensor. Zone systems that do not have one, lower cost zone control systems, you need a discharge air temperature sensor. And the reason why is because as you start to as the zone system starts to open and close dampers, or close and open dampers, depending on the system, they impact the dynamic nature of the duct's performance. So we need a discharge air temperature sensor in order to take action for protecting the equipment. So once again, having zone dampers gives you that additional means of balancing a trunk or branch line or a zone or room within the home by means of the mechanical stops. They're often easier to access as compared to the manual dampers that might be buried in the ductwork, already insulated by the time you start testing and balancing, and are often hard to find. The zone dampers, simply because of the actuator being exposed out of the insulation, are simply easier to find and adjust. So that's where your adjustable increments at the actuator come into play. By adjusting the maximum position of the actuator, you of course impact the ability to limit the maximum flow or the maximum CFM through that branch line. So if we look at what the system impact is of a traditional zoning system, of course, nothing wrong with this. This is what happens. If you have two zones, in this case, maybe we should have more, whatever, but it's a two-zone system, and both zones are calling, and shortly thereafter, the largest zone is satisfied. So the system begins to close the dampers. Once that happens, of course, we're dealing with, in this case, the premise was a single-speed or multi-speed piece of equipment. The fan speed and resulting flow and pressure starts to increase because we're closing dampers. So the question is, what happens to the trunk line or the branch line going to space number 1? What happens to the air volume going through that damper or going through that duct? Do we have complaints from the homeowner that certain rooms are always too hot or always too cold? And this can be attributed to improper rebalancing. And one great fix to such a problem is to actually add a bypass. It's often seen in homes that traditional zoning systems are installed, 2 zones, 3 zones in the system, and due to cost optimization or competitive bidding, it's often that a bypass is either frowned upon or simply left out due to cost reasons. And what I would like to do is discuss zoning with a bypass. So if we make the assumptions that the zone dampers will operate in a similar fashion with a discharge air temperature sensor, our one zone closes and we begin to build pressure in the ductwork in order to push air through the remaining smallest zone, which, as we know, results in overpressurization, over supplying that room with energy, or BTUs. It also is a comfort problem in the sense of the audible noise that's generated as velocity increases across the face of the diffuser. The homeowner starts to hear discomfort because of the air noise. So if we install the bypass in those existing applications, again, as a problem solver, we can begin to take control. And of course, Baluna does offer a pressure bypass damper assembly. And the assembly comes with a pressure tap for the supply air, and a pressure tap and hosing for the return, so that we can measure the pressure differential across the air movement. And what the pressure bypass does at this point is it's designed to be a standalone system, so it's not integrated into the zone control system. It could be standalone, just needs 24-volt power. And its design purpose is to control the pressure in the duct in any zone condition or any zone combination of ductwork. So as a direct result, when the zones are satisfied and we start to see an increase in pressure on the supply duct side as compared, of course, to the return, the pressure differential, the pressure bypass actuator's job is to measure and use the pressure differential as a set point so that when we start to see an increase in pressure, we absorb that increase through the bypass and then control the duct system to the installed duct differential pressure, which means we are not going to overflow the remaining smallest zone. So the airflow going into the space has both the comfort criteria for ambient temperature, and it also has the ability to satisfy or eliminate any noise that may be seen at the register in the room. So the pressure bypass, this is a product, again, that's a standalone assembly, applied 24 volts. It also has a setup procedure that it goes through. You simply push a button, and the actuator learns the damper's open position. It measures the pressure, drives closed, measures the pressure, and essentially at that point, the bypass is installed, commissioned, and will absorb any of the pressure increases in any zone combination from that point. Very simple. So, I missed one arrow there. So, as the airflow through the bypass, or the pressure is relieved through the bypass, of course, we return that air volume, whatever it happens to be, back through the return in a mixed air state. So the topic of the discussion is air balancing. The main goal is to add value to the overall process and improve the way things are done. And so what I want to present to you next is our position in the marketplace. This is actually quite interesting. This is a picture from 2005 of a crowd of people at St. Peter's in Rome, waiting for the Pope to start speaking in 2005. You can see a few people with cameras, you see a few lights. Of course, you can see a flip phone in the lower right-hand corner. This was a picture of this, essentially the same event at St. Peter's in 2015. Striking contrast of technology being deployed in simply 10 years. So as we look at various computing platforms, as we look at technology available to the consumer as well as technology available to the contractor and the technician, we start to see that the price of devices has come down over time, and of course the performance increases over time. So essentially you're getting more for your money with various devices. Our industry is taking a close look at how can we better utilize these devices within our practice for both testing, balancing, commissioning, sizing, selection, contacting our customers, interacting with our customers, and various solutions are coming out into the marketplace. Well, how is this important for Belimo? In the commercial marketplace, this slide changes. Where this technology can be seen in the Baleno portfolio on the commercial side is a great example is the energy valve. Where this is a complete valve assembly that measures the energy flowing through it. It demonstrates back to you or to the building owner the coil performance, which was never seen before, providing transparency of where the energy actually is being consumed in the building. And then it has built-in algorithms that help the valve assembly manage energy more efficiently, more productively throughout the building. So what I can contend to you is that there's enough technology in this energy valve to control a home as far as the HVAC is concerned, or to interact intelligently with the HVAC system in a home in order to make energy transparent in the home. So here's an example of a very similar actuator that you saw on the energy valve. And what can we do with it in the home? Well, there's a lot of technology built inside that enables us to raise the intelligence level of the actuator. It's embedded Java with the Linux platform, which simply means it's got a lot of computing power. The product also takes advantage of the fact that we can connect multiple Baleno actuators over a Baleno communications bus that we call the MT bus, a multi-point bus. So what we can do is connect up to 16 devices on this one intelligent actuator, or master, as we call it. These MP actuators, or MP communicating actuators, also have the ability to connect standardized sensors to the actuators. So we don't require a Baleno specific unique sensor. You can use any R2D or thermistor that's available in the marketplace. Our goal, once again, ease of use for all. Ideally, plug and play for the contractor. Get on and off the job quickly and cost effectively. What that means also is plug and play. The complexity of balancing, for example, can be embedded in the actuator. This same device can connect externally from the home through either cellular technology, to be able to install a box in the home that connects the Ethernet of the actuator over to be able to remotely access this information. Or of course, if Wi-Fi is in the home, using the already installed wireless signal within the home to access a Baleno cloud infrastructure. So when we look at smart zoning and the buzzword, the Internet of Things, how is it working at Baleno? We're looking at smart zoning leveraging the cloud. Over this Ethernet connection, we can make a connection to other intelligent actuators that can be deployed in the home. So not only for zoning, but maybe for hydronic heating and cooling. We have hydronic heating. We have hybrid systems typically installed in the home. We also have the need for possibly a safety water shutoff application in the home as well. So connecting one intelligent actuator to another is enabled. What this also enables us to do is allow or enable third-party companies to interact with our smart zoning system, as an example, through an API, or an application programming interface. What that simply means is we have a wireless thermostat in the home, and wouldn't it be great that that wireless thermostat can communicate to the zoning system without the added complexity and cost of adding hard wiring from the zone thermostat to that actuator that serves the zone. So based on today's technologies, you can do that using application programming interfaces. And of course, with this technology platform being Java and Linux based, there's the ability for us to develop a web page that is delivered or presented directly from the application. Now, once again, if we think about balancing, what does this mean for us? Well, now think about all the aspects of how difficult it is to balance a system, or the time that you need to invest in making it correct. And we could integrate that zone and balancing logic directly into the actuator so that we can enable a true plug-and-play self-balancing system right from the get-go. And then as a result, what we can present to you as a contractor, as an installation and commissioning agent, we can provide you with a tool to present back to the homeowner that shows them that your design criteria and your as commissioned criteria are now equal, and the comfort expectations of the homeowner can be now achieved. Then, of course, if you need to modify the system, you can do it remotely. So, I'll give you a quick picture, a quick snapshot into the future for Belimo Residential. And today, what we have are 4 different damper lines available with on BelimoResidential.com. And they are damper lines that are compatible with all existing zone controllers that are in the marketplace today. We're not selling the zone controllers, we're selling the damper sockets. One line that we're looking to expand to is to take advantage of a constant air volume application in the home or in the HVAC system to enable one step towards improved balancing. So, for example, these products will have an airflow sensor built into them, both what we call in-duct mounted or externally mounted. And what we'll do is take advantage of modern communications, so using a mobile phone or a mobile device that is Android enabled. We have incorporated into this actuator near-field communications technology. That means that the cell phone or the mobile device can communicate to the actuator without the addition of any wires, cables, or test devices. We can connect the app in the phone over near-field communication and pull various data points out of the actuator. So, such as, in this particular case, we can demonstrate that, okay, you installed a 6-inch round damper, and you would like, as your design criteria, you would like 200 CFM to go through that damper. It's a little high, but just as an example. So simply select the size of damper you have, enter your desired flow, and using near-field communication, put that flow set point back in the actuator. And essentially it takes maybe 30 seconds to achieve the proper flow that you're designing for that particular zone, at least at the zone damper in the branch run. You still should check what the flow is through the register, but at least now at this point, if your register flow is slightly off, you can go back to this application here, adjust the CFM. Maybe you want to go up a little bit, or maybe you want to go down a little bit, depending on what you actually measure. And using, again, near-field communications, put the new value back in the actuator and move on to the next one. And the really cool thing about this, as I mentioned in the beginning, with pressure-dependent systems, if you adjust one pressure-dependent device, it affects the others. With this solution, this constant air volume solution, once you have a flow set point, adjusting the other devices will not increase the flow through this device. So it'll be one step closer to pressure independent. So the maximum flow will never be exceeded. So this is another damper line that we'll be releasing relatively shortly. I'm not going to put a time frame on it yet, but it's something that's going to come out. So time is running down, so I see. I'll just give you a quick summary and then open for questions. So just to give you a summary, Belimo enters the residential marketplace with BelimoResidential.com. We have, once again, standardized damper assemblies that are compatible with pretty much every zone control system that's out there, available on that website, including the pressure bypass dampers that I mentioned earlier. And just a quick current state, simplicity versus complexity. We like to make things difficult and in our industry, and Belimo likes to look at those as opportunities to improve how we do our business. So there's tons of opportunity available out in the residential marketplace. And as a result, based on the Internet of Things and smart zoning, modern technology, we feel it's time for a new dimension of home comfort solutions out in the marketplace. So with that, I think we'll get Lisa back online here and open the floor for any questions that may be out there. Of course, what you can do. Yeah, go ahead, Lisa.
Oh, well, thank you so much, Chris. I think now we'll open up for some question and answers. Please type your questions into the question box, and then I'll read them aloud to the group. If you think of questions after the session, please email marketing@us.belimo.com. So right now we'll take any questions that you may have. I do know that there was a Wolf and Knoll asked for the presentation, and we will send that to you. Again, just email us at marketing@us.belimo.com. Here's a question for you. We typically design small buildings with 2 or 3 spaces with cooling loads of about 1 ton cooling. Will this product be practical for small commercial buildings?
To answer, you can still hear me, Lisa?
Yes.
Yes, okay. Yes, for light commercial applications, there is the in-between market for light commercial versus residential versus a true high-rise commercial building. So yes, there is some overlap opportunities, yes.
Okay. And then we have another one. How far down the supply duct do you suggest installing the PT probe for the bypass damper controller?
It depends on the actual system that's installed. The probes that come with the assembly are provided with 10-foot runs of tubing. So relatively close, but yet close enough that, or far enough away that we can get a true pressure measurement of the supply and the return before any transitions in the ductwork.
Okay, great. And can we get training locally?
Absolutely. Of course, through marketing at us.belimo.com. Of course, on the Belimo residential site is all of our contact information, including mine. And we'd be happy to come and visit in order to provide additional technical training. Absolutely.
Okay. And also, I'd like to tell everyone, in the handout area, there's also a line card of the Belimo residential products. And from that, I'd like to ask another question. Is Belimo selling damper assemblies?
Well, the answer is yes. The BelimoResidential.com website has the complete portfolio available. And it's a good intro to the handout that's available in this webinar screen over on the right-hand side where it says handouts. So the portfolio in the handout and on the website, you'll be able to see all the solutions we have available.
Okay, great. Well, thank you again, everyone. And if you have any further questions, please email them at marketing@us.belimo.com. Once again, thank you for attending today's webinar. And I'd also like to say thanks to Chris. If you should like a copy of this webinar, it will be recorded and it will be put on Belimo Air Control's YouTube channel. Be sure to join us for the next webinar, which is steam valve sizing and selection, which is May 11th at 1 o'clock. And thank you, everyone. Have a great day.